It's time for 5-11. We are going to buckle up and look at motion at a constant speed. I will warn you, this is kind of a long video. I'm going to do an explanation and then we'll get into the homework. So if you thought you would just go quickly to the homework, I guess you're just going to have to wait for it to load, or you can listen to me talk. So we're going to pretend there are two cars. There's going to be a yellow car and a purple car. They will be terribly drawn, but it works, so judgment-free zone. So again, the yellow car and a purple car. These cars are going to go different miles per hour, but they're going to go for the same amount of time. So this yellow car, it will be going 60 miles per hour, and the purple car will be going 50 miles per hour. The way we're going to look at this is using a line, so we can really see this number line with the miles per hour and the hour attached to it. So I don't even know why I'm trying to get so fancy with these cars, but just imagine with me these two cars. So this yellow car, like I said, goes 60 miles per hour. You could do this with a double number line. In our case, I'm just going to draw one and we can visualize. So at 0 miles per hour and at 0 hours, the car has gone nowhere, so everything's a 0. But after 1 hour, because the car is going 60 miles per hour, the car maybe just averages that, cruise control, whatever. The car has gone 60 miles. So I know you see me, right? I wrote 60 miles per hour. The car has gone 60 miles. So after 2 hours, the car will have gone 120 miles. This is keeping a constant speed of that. After 3 hours, the car will have gone 180 miles. This is without anything stopping it. There's nothing, no stoplights, no crazy other cars, either way. So after 4 hours, the car has now gone 240 miles non-stop. So this purple car, like I told you, it's going to go 50 miles per hour. And we're still going to check it at the same points though. So 0 hours, 1 hour, 2 hour, 3 hour, and 4 hours. So after 0 hours, the car has gone 0 miles. It's gone nowhere. Vroom, vroom, but it's at a standstill. After 1 hour, the car will go 50 miles because this car averages 50 miles per hour. After 2 hours, the car will go 100 miles because it's going 50 miles per hour. Nothing is stopping it. This car can just go. I've done the drive from Nebraska to Washington many times. Maybe it's on the highway in Wyoming. After 3 hours, it goes 150 miles. And after 4 hours, it's gone 200 miles. Notice it's not 200 miles per hour, it's 200 miles. So there are two variables we're looking at, a dependent and an independent. So when these things are related, we know that there's a dependent variable and an independent variable. The distance that we're going and these cars are going, the distance that they go depends on the time. So after each time, they're going a different distance. But the dependent variable, it depends on the time, is the distance it goes. The independent variable is the time. So we're going to graph this when we look at the homework, and we use the X for the independent and the Y, so that'd be like the one going vertical, the Y for the dependent. That independent is what they share together, right? They share the time, but they are going different distances. So let's dive right on into the homework. A student walks at a constant rate of 9 feet every 2 seconds. Well, this is a tricky double number line because it actually has it split up into 1 second, 2 seconds, 3 seconds, 4 seconds. I can immediately fill in the feet for 2 seconds, right? Because it's 9 feet every 2 seconds. So I could just put 9 right there. But if I'm looking at 1 foot, I'm going to have to do some math and really think. If I go 9 feet in 2 seconds, so in half that time, how far will I go? I will go 4.5 feet. So every little chunk is 4.5 feet. And that's for this entire double number line. So at 3 seconds, I will go 9 plus 4.5, which is 13.5. And then at 4 seconds, I will go 18. So now we're going to complete the table. At 0 seconds, well, you've gone nowhere, so it's 0. So after 1 second, we can look above, it's 4.5 feet. After 2 seconds, we look above, and it is 9 feet. And I already know 4 is 18 because that's double that. And after 3 seconds, it's 13.5. After 5 seconds, I need to add 4.5 feet, and it ends up being 22.5. Now, my T is the time that's elapsed. The D is the distance. So if I needed to write an equation, it would be this distance is equal to T times 4.5. Remember, I'm every second going 4.5 feet. So I could put in any number for that, and you'll see me do 6, and I multiply 6 by 4.5, and I get my answer. So I really shouldn't have set it up this way, but 6 times 5 is 30, put down a 0, carry the 3, 6 times 4 is 24, plus 3, I believe I write 28, but I go back and I erase because that's why pencils have erasers. It's like I knew that is not right. It is 27. So after 6 seconds, my student, whoever, or maybe it's me, goes 27 feet. So let's graph it. The seconds elapsed are on the X. The feet walked are on the Y. So at 1 second, this student goes 4.5 feet. At 2 seconds, this student goes 9 feet. At 3 seconds, this student goes 13.5 feet. At 4 seconds, this student goes 18 feet. At 5 seconds, the student goes 22.5 feet. I mean, I could go on and keep graphing it. I'm not going to. I'm just going to stop where we're at. But I need to make sure I make this a line, and I go all the way down to 0. I mean, you could totally use a ruler for this. That works. And I do have my little triangle that helps show my how it all links together. It is kind of crazy to look at these distances with anything, whether it's a car, walking, really anything, and see and be able to pick out the dependent and independent variables. The more you do this, the more you'll be able to see that on your own. It is kind of cool being a mathematician in real life. So I have our formula. D is equal to 4.5 times T. Remember the distance we walked, 4.5 feet times the time. So I will do 4.5 multiplied by 1.5 because that's 1.5 seconds. Remember, we are still doing, after 1 second, it is 4.5 feet. So now I plug 1.5 in for T, and I get an answer of 6 3/4 feet, which actually totally makes sense because it's right in between that 1 and that 2, because it's 1.5, right? So I could write 6.75 feet. I could write 6 3/4 feet. Either way, it's that 6 3/4. I'm going to set it up the same way for 3 2/3. I plug that into for my T. T is the variable that I put in the time, and I get 16.5. Another student walks at a rate of 6 feet per second. Write an equation relating these two things, right? So my distance, I don't know my distance, but I do know that because I want my distance to be this unknown, right? So 6 feet per second. So after 1 second, 6. So I'd multiply T by 6, and I would get my real distance.